Okay, let's look at the first derivative test for a local maximum or local minimum. Right? So let's say C is a critical value of f. Right? There are three cases. Right? First case, right? Around the critical value C, right? The first derivative goes from positive to negative. Right? So let's try not to memorize this. Just you need to understand what this means, right? If derivative positive, then it's increasing before C, and after that it becomes negative, which means decreasing. So the graph we're looking at is ballpark picture is increasing, turning into decreasing. Then we're looking at the value there, right? So we know that if the derivative goes from positive to negative around C, f of C must be a local maximum. Right? If, for the second case, if the first derivative goes from negative to positive, which means that the original function is decreasing before C, after that it's turned into increasing, and we're looking at that point right there. So we know that f of C is a local minimum. Right? And the last case is that the derivative doesn't change sign, so it's either positive to positive around C, which means that it's increasing, and after that critical value it's still increasing, right? Or decreasing to decreasing, so you have a decreasing picture, right? But you have a critical number, but still decreasing, right? So you can see that either case you do not have a local max or local min. So in this case f of C is neither. Right? Let's apply this first derivative test to determine f of A, f of B, f of C, f of D are local max or local min. Right? So if you have a function defined, it's continuous on all real numbers, right? And these are critical values, right? So these are critical values here. This is critical value, and C is also a critical value, and D is also a critical value. Right, so at this point we want to determine if we have a local maximum or local minimum. Right, let's look at this. Right, around the critical value A, it goes from positive to negative, so we know that this guy is a local maximum. Right, how about B? Right, B, around B, derivative is negative to negative, so there's no sign change, which means that f of B is neither local max nor local min. How about C? Right, around C, it goes from negative to positive, so negative, positive, it's a local minimum. Right, how about D? Right, there's no sign change, positive to positive, so this guy is neither. Right, so by having a sign chart for the first derivative, we can use the first derivative test to determine if at the critical value we have a local max or local min or neither. All right, that's it. I hope that this was clear.